Hello and welcome to another section in further mathematics. Today I will be talking on the topic vector. But before we proceed, I want us to do a quick review on our previous lesson. Okay, welcome back. Now, before now, we have knowledge that vector talks about magnitude and direction. One thing that makes vector unique from scalars is that a vector quantity has both magnitude and direction, while a scalar quantity has only magnitude but no direction. Now, talking about the magnitude of a vector, sometimes called the modulus of a vector, is represented as the absolute value of such vector. So if we have a vector 4 plus 4i plus 3j, the magnitude, let's say a is equal to this, the magnitude of this vector can be represented as a absolute value of a, which is the same thing as the square root of, we have 4 square plus 3 square, which is equals 4 square is 16, 3 square is 9, so which is the same thing as square root of 25, which is equal to 5. So the magnitude of it is equal to the square root of the square of the individual component of the vector. Now, talking about the zero vector. Now, what is a zero vector? Is a vector that has zero magnitude. So if after looking for this and you discover that the magnitude of this vector, okay, we had something like square root of 0 and our answer is 0, then it is usually referred to as the zero vector. Then what is a unit vector? The unit vector is a vector represented by a and is such that our a is equals to magnitude. So in a case where your a, the value of the vector, is equivalent to the magnitude of a vector, then you call such vector a unit vector. But if a negative vector is written as a minus the original vector, two vectors are only said to be equal if they have the same magnitude and the same direction. Now, I would like us to do justice, but remember the word magnitude and modulus are the same. Now, I said let us perform some calculations that has to do with magnitude and modulus. Let's call this our example 1. Let's call it our example 1. You might be told to find the magnitude. You can still call it the modulus of the vectors below. Now let's say the first vector is a. Let's look for the magnitude I plus 4j. I think we've done something like this, and I said in getting the magnitude is the absolute value, and the formula is the square root of what's here 3 square plus, and what's here 4 square, so which is equal to the square root of 25, because from what you have here, you have it that 3 square is 9 plus 4 square is 16, so your value becomes 3 plus is 25 and equal to 5. So the magnitude of this vector is 5. We can do for another vector by writing, let's say this one is minus 2i minus 5j to be equal to let's call this b. Now you know the rule, minus 2 all square plus minus 5 all squared, which is equal minus 2 squared, remember the square root, is equal to 4, plus minus 5 squared is equal to 25, so it's equal to root 29. Since we can't express it further as since 29 is not a perfect square, we leave it in this format. Now this is just how to find a unit vector. You can go ahead in writing so many vectors. You can write 4i minus 3j. They are still vectors. Okay, let's leave minus 3 and 4. Let's use 5. You can still use 5. So the unit vector of this will now be equal to the square root of the modulus or magnitude will now be equal to 4 square plus minus 5 square, which is equal to 4 square is 16 plus, because 5 square is 25, and 16 plus 25 is square root of 41. So this is just the magnitude of how to get magnitude of a given vector. Now let's go into solving another question. If r, that is r1 equals 7i plus 3j, this is for r1, and r2 is equal 2i minus 5j, find the modulus and direction cosine. Find the modulus and direction cosine of 1 r1 plus r2 and 2 we'll call it r2 minus r1. Now before we start, let's get our r1 plus r2 and r2 minus r1. R1 plus r2 is just a simple addition of vector. So we have our r1, 7 plus 2 is 9i, 3 minus 5 minus 2j. So this is the value of our r1 plus r2. Then our r2 minus r1. Now this r2, remember there's no minus sign here. Now we have r2, 2 minus 7 is minus 5. So this point, our first point here is minus 5 I. Then we now have remember it's r2 minus r1. We now have minus 5 minus 3 is minus 8j. We have these two values, so this is what we are working with. Then the question is, if this, find the modulus and direction cosine. Now let's get the modulus of this. The modulus of r1 plus r2 is now like this, which is equal to square root of 9 squared plus minus 2 all squared, which is equal to square root of 81 plus 4, and is equal to square root of 85. Now when we talk about the direction cosine, now for the first we say is cos this is equals 9 all over root 85, and cos beta is equals minus 2 over root 85. This is the direction cosine of this vector. We are done with this. Now let's do for this r2 minus r1. Let's get the modulus first. Is equal to, you open your square root, minus 5 all squared plus minus 8 all squared, which is equal to minus 5 all squared is root 25 plus 64. Now 25 plus 64 is 89. 25 plus 64 is 89. So we have our r2 minus r1 modulus will now be root 89, and with this the directional cosine will be cos. What's the value? This equation, minus 5 over root 89, and cos beta course, beta will be equal to minus 8 over the modulus root 89. I would like to say a very big thank you for joining us in today's lesson. In order for you to refresh your memory on the concept we've just finished discussing, I would like you to take the test that will be appearing shortly on your screen. Thank you.